Inside the rating section in the mixer, you will find out that there is only one section for the rating or the sizing, which is the nozzle. The nozzle is like the inlet and the outlet section for the mixer. So the mixer is mainly a chamber with an inlet and an outlet, different inlets and an outlet. Okay, so if we look here to have an idea, this is the nozzle and this is also a nozzle. So here we have an outlet, which is the water, and here we have, it could be an inlet or an outlet. This is like a cross section, but makes more sense if it's an out. Okay, so if we look, this is a separator, and here we have a gas outlet. So here this section is called a nozzle. Here we have a water produced, it is getting out from a nozzle, and we have oil emulsion inlet. So this one is a nozzle, this is also a nozzle. See, so if we have a mixer, it will be like this separator, a chamber. We have different inlets, like we have inlet from here and inlet from here. Okay, so this is the nozzle. The nozzle here has a diameter and also has an elevation. So if this is the ground and we have our separator put here, so this one is the ground, G. This blue section with like a 0.5 meter height, so this one is a base. So we can have a ground and we put our separator into a base, so it will be higher, like 0.5. Okay, so we can define the position from a ground or from a base. From the ground, this one 0 because it's put on the ground. If it's on a base, it will be 0.5 meter for this height. We have our vessel here. Each nozzle has diameter. Okay, so if we go back to this section in the rating, we will have that we need to define the natural gas feed diameter. What is the diameter of the nozzle for this one? So this one is entering the mixer through a nozzle, and we are asked about the diameter. Also for the water to mixer, this one, this stream is entering through a nozzle. If you have information about the diameter, it's always recommended to add it here. So feed with water, this is your outlet. What is the diameter of the nozzle of the outlet? So the mixer inlet nozzle is designed mainly to introduce fluid into the mixing chamber. It's often have a specific geometry to enhance the mixing efficiency. Also for the outlet, this is our outlet stream. This allows the mixed fluid to exit from the chamber. Okay. What else we need to know if you have information about the diameter? So here the elevation could be defined according to the ground, also the base. The ground means you have added your item or unit operation into the ground. So to the ground, it means it's always 0, right? It's on the ground. You have no elevation. We are not burying and put it under the ground. Okay. The second one is from the elevation. So in the previous examples that we were talking about here, this is the base, and we were talking about 0.25 meter. So it's like a quarter of meter above the ground. So if you have any information about the base, you can add it over here. Okay. After that, we have the worksheet. The worksheet is mainly for the data entry for the equipment. So you can here have your inlet, which is natural gas feed and water to mixer. All the condition will be displayed over here. You can change it, like if you want to change the temperature of the inlet, like this one, instead of being 30 and this one is 25, the outlet here is 18. You can maybe increase this temperature like for 40, and it will affect this one. If you look here, it's increasing. So if I want an exit stream to be like in 20, we are looking for maybe 35. Okay, we can go up like 36, and okay, this one was fine. So I need to increase the natural gas feed temperature to 36 to mix it with water of 25, and we are having a temperature of 20 degrees. Okay. Again, one important information to know that if we look here, the vapor, this vapor is the vapor fraction, which means 1 means all the composition is vapor. This one means all the composition is water. But if we look here, our outlet here can't be fit to a compressor or a pump because it's a mixture of a liquid and a gas together. So here we have 0.9. I want this one to be 1. Okay, what does this mean? I want to increase the temperature. Being 1 means moving from the liquid phase to a gas phase. So I want to increase the temperature. So I can increase this one to maybe 40 and check. So this one could be 42. Or we can increase the pressure. So this one, I have put it to the minimum. So I want to increase both of them. So if this one is 1.5, okay, so it will not be solved again. So 1.1 and okay, why it wasn't solved? Because I have set to the lowest and I am changing the lowest over here. So you can keep increasing the temperature like this one at 100. So this is a complete water at the atmospheric pressure, and 100, this is the boiling temperature of water. So this is only water. Okay, so this one will be 1 and it will lead to this one to be 1. This is a high temperature, so we can lower the temperature here. So like if this one is 25, okay, it will be affected. So 30, okay, so 30, 100, here we have 100% water. So this stream could be fit to a compressor, okay? But in practical, we usually add before the compressor a knockout drum to make sure that our stream to the compressor is free from any liquids, okay? So what I'm here talking about the condition, we can change the condition over here and it checks our product. It will be vapor, a liquid, what is the temperature, and also what is the pressure. So I'm setting this back to the normal temperature 25 and this one to a 30, okay? And also this is after mixing 520, it will be 520. This is a simple mass balance in equal out. We have 500 in and 20 in, so the total will be 520. But this is not the case. This is a steady state. But if we look at a dynamic state, we can have accumulation inside the mixer. Like the mixer, okay, let me talk about this. If I have a mixer over here, I have an inlet of 10 and another inlet of 20. So the total here will be 30, but the outlet here could be only 25, not 30, because I have 5 kilograms, if the unit is kilogram per hour, so I have 5 inside accumulated inside this item, okay? So it's different between having a dynamic and a steady state. For here, for the properties, it will be the same way. The properties printed for the feed and also for the products. You can check any properties that you want to know about the values, like the viscosity. It will be printed over here. For the composition, it's simple. We have a water stream, but if it's a more complicated, it will be way more better to go to the composition over here. You can change the composition. You can maybe remove water or add more water. It's up to you. This one, for the PF spec, the PF spec is related to the pressure flow specification, and this is the core of understanding the dynamic simulation. So in our next video, we will start talking about the dynamic simulation of the mixer and the PF spec.